numbers like the square root of 20, the cube root of 125, the fourth root of 15 are all examples of radicals. We've already discussed a lot about radicals, but we have some definitions that we just need to go over. Right here. That's your index. What's up? Okay, we'll deal with that. Right here is your radicand. You guys had a question on that earlier this week, right? Perfect. If there's no index, that means your index is 2. If the index is an even number, then the radicand has to be positive. If you can't take the root, an even root, and come up with a negative answer, right? Okay, next page. It's not going to come up on the board, but I have a copy here. So, it says just as with fractions, equivalent expressions for any number have the same value. So when you have your root sign, that radical sign, the number underneath it, see how it says 16 times 9 equal to 16, the root of 16 times the root of 9? Actually try it out. See if that's true. So, if it's underneath the radical sign, you have to do the multiplication first. What's 16 times 9? Alright, what's the square root of 144? 12. Alright, so now do the square root of 16 by itself.
4.
And the square root of 9 by itself.
3.
What does that multiply to be?
12.
Oh, exactly. So either way you get to the same point, right? So that means we can take things underneath our sign and break them up. So x times y can be broken up to be like that. Which do I find easier? It depends. It's nice to break it up this way, but sometimes you're going to have to go the other way too. So the plus side of this is that if you can find a perfect number, just like the square root of 9 becomes 3, you can make that other number a lot smaller. So you can divide out perfect cubes. It works for cube roots too, right? So look underneath. Try this one. The cube root of 27 times 8. What's 27 times 8? Pardon? 216. And then what's the cube root of that? So these all connect, right? Now break them apart. The cube root of 27 and the cube root of 8. The cube root of 27 is 9?
3.
Check your calculators.
It's 3.
It should be 3. And the cube root of 8? 2. Which is equal to 6. 3 times 2 is equal to 6. So everything we're doing today is off the basis that we can do that with our radicals. So it says right there in your notes, we can use this property to simplify square roots and cube roots that are not perfect, but have factors that can be perfect within them. So flip your page over. something called an entire root. We have two terms we need to know. Mixed and entire. An entire root has everything underneath your radical sign. A mix has a coefficient, and what's a coefficient? A number in front that's multiplied. So on your example there, the entire radical, it says the square root of b. Your mixed is when you have some coefficient in front of it. What you guys have to do by the end of today is you're going to have to convert all of your entires from this form to that form.
Ow. Ow.
We're going to use our properties that we just talked about. Give this one more try and see if it works.
Here.
Yeah, not happening. Okay. Flip it over. We'll do a couple examples together. Maybe you'll do a couple on your own. So, the first one. 8. Square root of 108. What is it? 10.39. If your answer comes out to a decimal, then we're not happy. We want to convert it into a mixed. The way you do that is you have to try to find those perfect squares that we talked about a couple days ago. So your perfect squares were like 4 and 9, 25, 36. Yeah, to get a different. So you want to find one of those. We'll make our chart real quick. You want to find one of these numbers that multiplies in your radicand. You want to find the largest one that divides in your radicand. I wish I had the second color marker. You want these numbers right here. Or 36 is the next one, and 49. What's the largest one of those that divides into 108? 10's not on our list.
11.
Is 11 on our list?
Wait, have we just on the list or can it be like 100?
What does 100 divide into 108?
Oh, never mind.
You need one of these numbers to divide into your radicand, which is 108.
9.
Is 3 one of the circle numbers?
9.
Oh, 9. 9. Go slower. Yeah.
18.
Is there any other number that divides in? Carter. 36. So you got to pick your largest one. That way you don't have to do so many steps. So we'll do it both ways. You can break it into 9. The square root of 108 is equal to the square root of 9 times what? When you took 108 divided by 9, what'd you get? 12? Our property tells us we can break those numbers apart. Do it 36 over 2. I'll show you how, yeah? It'll actually be quicker. So the larger the prime number you find, the quicker you'll get to your answer and the less work you have to do. What is the square root of 9?
3.
Right. This just becomes 3 times the square root of 12. The problem we have here is in a couple days you're going to have to get it to the simplest form, which means you're going to have to try to get the smallest radicand you can. And 12 can be broken down a little bit further, because one of these numbers divides into 12. 4 does. So that would become, up here, I'm just going to do the square root of 12 is equal to the square root of 4 times 3. Right? You have a question or you stretch it? Okay. This you could break apart again, and then you'd have to multiply your coefficients. It's a lot more work when you do it this way. If you find the largest one that goes in, like Carter did, he chose 36, correct? 108. Remember what's your remainder when you did 36? 36 divides into 108 3 times? Does everybody follow that? We broke 108 into 36 and 3. Our property told us we can break those into 2 separate radical statements. The square root of 36 is 6. The square root of 3 is left as the square root of 3. Check your answer. If you did the square root of 3 and then multiplied it by 6, you should get the same thing as doing the square root of 108. If you ever do that check and don't get the same number, you lost something on a step, and you need to go back and take a peek. We will do, let's do E together. Hurry and try to write that down. And we'll move on to E. Did I say E? Okay, we'll do E. When you do this one on your own, you need to use this chart. It's the only one where your index isn't 2. There's a little 1 in front of D here. No. Just treat it like it's 3. Ignore that little 1. I think it's, I'm not sure why there's a line there. I think it's just a mess up. Everyone think they could do C now on their own? Yeah? You'll give it a try in a second. E. What's the difference with E compared to the other ones? It's got a number. What do we call a number, guys? Coefficient. The important thing about this is to not forget that you have a coefficient. They have a tendency to disappear as you guys are working. So we need to carry that coefficient as far as possible. How do we break up that radicand? We want to get that 192 to be smaller. How do we do that? Square root it. If you square rooted it, what would you get? A decimal. What do you get here? We just square root of 192. $13.85? That's no good, right? So what do we want to do? You want to divide it by the largest number that we can find over here, right? In the square column. What's the largest number? We got 64 as a suggestion. $64 is just the next number down here. You guys aren't going to have somebody sitting here saying out to you what divides into that number. So you should be testing it on your own calculator. You're not going to have someone stand there and tell you that it's 164 or it's 12 or whatever. What do you get when you take 192 divided by 64? 3. Okay. This 2. Keep it in front all the time. The square root of 64 times the square root of 3. Where did that 3 come from? Michael got it from going 192 divided by 64. How did he choose 64? He looked through his column for squared things because his index was a 2. What's the next step? You break these things apart. You do. It still remains. Times that by the square root of 64. Times that by the square root of 3. Everybody happy with that? Seems pretty legit. What's the square root of 64? Now you have this. And the last thing you need to do, multiply 2 and 8, correct. You need to multiply those coefficients. So your final answer should look like this. With a box around. That is you converting a radical into mixed radical form in its simplest form. When you did the square root of 3 times 16. Give it a try. Everybody go square root of 3. And then multiply it by 16 and tell me what you get. Good? 27.7? We agree? Okay, so go back to the original question. Everybody do the square root of 192 in your calculator. And then you have to multiply it by 2, right? What do you get? Perfect, then we did it right. Go ahead and work on these other ones that we haven't done. B, C, D, and F. Work with someone around you if you have to, then we'll go over them real quick. Let's go over these together. For the square, okay. For the square root of 25, the first question I need to ask myself is, what is the index? 50, yes, our square root of 50. What's the index of this question? It's 2. The index is the little number that's right there. A lot of you guys are struggling with that, and that's not something new. You guys need to turn around and focus here. You have these questions. There's no number there. The index is 2, which means we work off our squared chart that we created. The index is 2, so we look at the exponents that are 2. We need to find the largest number from this table that divides into 50. Matthew, 25. That means we can break it up into the square root of 25 and the square root, what's the number that goes into there? Why 2? Because 2 times 25 gives you 50. Correct. You could do square root of 2 times the square root of 25. Yeah, that also works. Multiplication, you can change the order and it still works. Josh? Yeah. Yeah, that's exactly the answer. So, the square root of 25, the reason that we're picking numbers from this chart is because it's going to give us a whole number. So the square root of 25 is equal to what? 5. Times the square root of 2. And that's your answer. That's it. You're good. Got it? Attaboy. Yeah. All right, over here, cube roots. What's our index? 3. So, which chart do we have to look at? Cube root chart. What's the largest? Jared, you're not allowed to get very long. I thought you guys could, but it's not proven to be that way. What's the largest number in our cube root chart that divides into 6,000? 125. Now here's the trick. This little number here, you have to keep it through the entire question. It's not a coefficient, it's an index. So that means when we go to this next step, we need to keep that little 3 there. So we broke it into 125. And what's the remainder when we divided 6,000 by 125? 48?
Yeah.
The cube always has to stay there. Emma. Is there a bigger number than 125 that goes into it? 1,000?
Yep.
And that's 10 cubes. So yeah, that would work also. So this means, let's see where this takes us. What's the cube root of 125? 5. So this turns into 5 times the cube root of 48. But Emma has a great point. Because she said 1,000 could have gone into it. Which means when we get to this point, we need to look at this number right here and see if anything else from our chart can divide into it. So look at our chart. Any of those numbers divide into 48? 8. Does 8 divide into 48? 16? Is 16 on our cube chart?
Oh,
It's got to be the cube chart. These 3's never go away. Question.
If you multiply 2 versus 8, that divides 5 to 5. That makes.
So if we did this, so John, if we left it like this, 5, or Josh, sorry, 5 times, and we said that 8 works. So the cube root of 8, what's our remainder? If we do 48 divided by 8, what do we have under here? 6. We're not done. What's the cube root of 8 equal to? 2. So it becomes 5 times 2 times the cube root of 6. 5 times 2 is 10. So your final answer is 10 times the cube root of 6. We box our final answers. A few things. Don't lose your index. Something we constantly see is those 3's will all of a sudden disappear. Yeah, don't let them disappear into smoke. They're not coefficients, they're indexes. That's why they're little. Any questions about how we did that one? Hannah? Yes. T. So remember, we're forgetting this line here. What chart are we looking at?
That one's the question was it's actually a legit question, but when do you actually use this in the real world, I guess?
Okay, that's a good question. So, the overarching question of math, right? And Matthew, did you ask this? You asked this 2 days ago, right? Somebody did. That was Josh. Josh asked it. Oh, Dawson. And the answer I gave Dawson was probably not one that he expected. I don't know what you thought I was going to say, eh? You're not going to use this in real life for the most part, right? You're not. So, yeah, but why do we have to, but why is it part of the curriculum? That's a great question. It's a worthy question. What math is testing you is testing different ways that your brain's thinking and seeing how hard you're willing to work at something and seeing how well you can critically think and problem solve. So is it asking you how to make a mix to an entire or an entire to a mix? Absolutely. But what we're actually trying to work on is your ability to think critically and to work hard. Because those are things that you need to get through math. Plain and simple. The best example I gave was, I come from a family, they're all engineers. So my brothers are engineers, and they did all this math and all this science, and they never used any of it. like literally ever. But the fact that they were able to think so hard about math, critically and problem solve, is what got them to the point that they're at now, which is what gave them the job of being an engineer. So when they were hiring them, they didn't care if he could do prime factorization. What they cared about is that, oh, you were able to get through all these math courses. That's telling us that you're able to think critically and to problem solve, and that you're a hardworking person. That's why we study math, in my opinion. Fair? Okay. Yeah, no, that's a good question. I mean, everybody asked it. Okay, cube root of 54. We look at which chart? The cube chart, because our index is 3. Carter. It's 27. So Carter says we're breaking it up into cube root of 27 and the cube root of what, Carter? 2. Right? Because that's the remainder when you did 54 divided by 27. Cube root of 27 is 3. Multiply that by the cube root of 2. That's your answer. Next one. What's your index? 2. If your index doesn't exist, your index is 2. So what chart do we look at? The squared chart. What's the largest number on that chart that goes into 192? Emma. 64? Everybody agree? Anybody got a larger one? Go with 64, okay? 2 times the square root of 64 times the square root of, I think, 3.
I just did this.
You did you already? Yeah, we did it on the board. Perfect. F. A little harder. I'm going to give myself some space. Up here. Okay. Which chart are we going to look at? Because I'm good at somewhere. You guys are teaching me how to do it. Is it the magic pen?
Circle around and then
So you do this. Okay, so yeah, I'll try it over here. So you just do a circle around it,
and then click.
and then click.
Click in the middle.
Oh my
That's sweet. Thanks, Joe. I didn't know that. That's all. Yeah. I'm sitting here thinking you're a genius. I never did that. That's all. Okay. So which chart do we look at? Ladies and gentlemen. Which chart do we look at? The squared chart. What's the largest number that goes into 160 from the squared chart? 10 on our squared chart. Not just a guessing game. Get your calculators out and start punching numbers in. 16 goes in. 36? Test it. It's not a question. Give me some confidence. Tell me if it works or not. Did it work? Did 16 work? Check it. 16. 16 works. So, what you need to do, your 3 over 4, you keep. Then you do the square root of 16. And then you do the square root of 10. I'm not sure why I drew the index of 2 there. What's the square root of 16? What do we have to do with our coefficients? I know you guys know the answer to this. What do we do with our coefficients? Right? But we've gotten to this point. Is this the answer? Thank you. What do? We multiply them. So, 3 over 4 multiplied by 4. What's that give you?
3.
3. The answer is 3. Square root of 10. Any questions?
you get the
How did I get what? No, it's a good question. You're not the only one thinking it. How did I get what? Ella.
How do you check like the fractions?
Great question. Okay. So, in your calculator, you can do 3 divided by 4, and what do you get? And then multiply 0.75 by the square root of 160. And what do you get, Al? 9.486. Okay, and now try our final answer. Square root of 10 multiplied by 3. And you got the same thing. Yeah, that's how you can test your answer. A lot of you guys have the same questions, but you're not willing to speak up. And that's why I came back to the board and did them all together. Because the question I had there and there and there and there are all the same question. So don't be afraid to ask it. Exactly.